In the last video, we learned about probability mass functions. You can find the link to the video in the description. In a nutshell, a probability mass function is a mapping from a discrete random variable to its probability. That is, if x is the random variable that contains a set of events for each event small x belonging to x, the probability mass function f that takes as input the random variable gives the probability of certain event in the random variable as the output. The important thing to note here is the word discrete. A discrete random variable contains a discrete number of events associated with them. For example, within the range 0 to 1, the only possible values which occurred as events in our case are quarter, half, 3/4 and full. Now, suppose one day you went to meet your friend who lives 2 streets away from your home. You see an ice cream truck that sells your favorite brand of ice cream pass by the road. You want to eat that ice cream every day, and so you enquire your friend when this ice cream truck comes each day. To your disappointment, he says it comes every day at a random time. You think to yourself, if you can calculate the probability of the time at which the ice cream truck arrives, you can catch it most of the time, if not all days. So, you stay at your friend's house and then you start to take note of when the ice cream truck arrives every day. On day 1, that is Monday, it arrived at 11 am. On day 2, it arrived at 1 pm. On day 3, it arrived at 9 am, and so on. After a week, you look at the data collected. Out of 7 days, the truck arrived at 11 am 2 times, 1 pm 3 times, and 9 am 1 time, and 10 am 1 time. You almost conclude that the ice cream truck probably arrives most of the time at 1 pm, but just to be sure, you decided to stay at his house for one more week and take the data. This week, on Monday, the truck arrived at 11:10 am. On Tuesday, the truck arrived at 12:45 pm. If you had thought the truck would arrive at 1 pm and it arrived at 12:45 pm, you would still miss the truck most of the times. So, we can say that the time of arrival of the ice cream truck every day is not discrete but can be any time within a given range. This is called a continuous random variable where any value within a given range can occur as an event. A continuous random variable is defined as a range where any number within the given range can occur as an event. For example, if we consider a random variable x that has range 2 to 5, then all numbers between the given range can occur as an event, like 2.01, 2.003, 3.14, 4.0001, 4.2, and so on. Therefore, the number of events in the continuous random variable is infinity. It is not possible to find the probability of an exact event of a continuous random variable. For example, f of x is equal to 4.0001 is not possible to find. Let's go back to our ice cream truck example. What do you think is the probability that the ice cream truck arrives exactly at 1 pm? First of all, how can you measure exactly 1 pm? It may be 12:59 and 10 milliseconds. It may be 1 pm and 300 nanoseconds. Please note that all these values are valid in a continuous random variable. Impossible, isn't it? It is the reason why we do not calculate probabilities of exact values of a continuous random variable. Rather, we calculate the probability between range of values. For example, what is the probability that the ice cream truck arrives between 12:45 to 1 pm? What is the probability that the ice cream truck arrives later than 10 am, etc.? The function that maps a continuous random variable to its probability is called the probability density function. A probability density function is usually represented by a continuous curve. So, in order to find the probability of a range of events like we saw before, we need to find the definite integral of a function between that range, which means we need to find the area under the curve within the given range. This curve can be formed by recording as many data points as possible. The more points we get, the more accurate the curve will be. These are few examples of curves that represent probability density functions. If you like the content of my videos and want to see more, go ahead and click the subscribe button. If you know anyone who will benefit from these videos, please share it with them. Until we see in the next video, this is Tarun signing off.